Hello and welcome to Building Context. This is a series of videos that we're doing on APIs and API security and API-based applications, a series of tech talks that we're doing. My name is Chris Westfall. I head up product marketing here at Salt Security. And today, again, I'm joined by Michael Otzbitsky. He's our technical evangelist. Welcome, Michael.
Thanks, Chris. It's great to be here.
Awesome. We're happy to have you back again. We're going to continue the conversation. In the last episode, we talked about how APIs or applications have changed, and we're seeing a lot more APIs being used in applications. And we kind of ended on the note of how APIs have changed the landscape of security, really kind of working off the premise that APIs have broken the security stack in some way, shape, or form. So I want to dig a little bit deeper into that, talk about how they've broken security or how they've changed security, and see what we can do about it. See how people should be thinking about how they approach security for APIs. So, we talked about APIs being around for a very long time. I mean, they've been around for maybe 20 years now, but a lot has changed over the past 20 years. I think three big things have changed. Number one, there's a lot more APIs, and they're more exposed externally than they ever were before. Right? We think of APIs. A lot of people think about machine to machine communications and behind the firewall, but APIs are behind applications, web-based applications, mobile applications, and they're also obviously very prevalent behind the scenes as well in microservices environments, connecting to partners and whatnot. The other thing is that they're being used for a lot more business critical applications, right? They're powering bank apps, healthcare applications. They're connecting to your partner ecosystem, and therefore we're sharing a lot more sensitive data across these APIs. So I think not only is the attack surface bigger, but the stakes are higher. Should an attacker get in and actually be successful breaching an API, and therefore we're seeing a lot more attention on APIs when it comes to attacks, right? We're seeing a lot more API-based attacks. And the third big thing that I think has changed is that there's a frequency of change in APIs, right? APIs have become a core component of these applications. We've seen a big change over recent years to more of a dynamic development cycle around CI/CD, where things are changing on a constant basis. So not only do you have a bigger attack surface, but it's constantly changing as well, which makes it difficult. So maybe we can talk a little bit about how attacks in the world of APIs or attacks focusing on API-based applications are different from what we saw with traditional applications. We can start off with that.
Mm-hmm. Yeah, and it's the other thing I like to mention too, Chris, is a lot of infrastructure now is API based as well with cloud and certain container platforms, but also like build pipelines, right? You talked about development process and development accelerating and release processes, and CI/CD is kind of the heart of that. A lot of that is API traffic, that kind of controls your pipelines. So failing to secure those build systems can actually have some very unintended side effects of your how you build software, right? It kind of becomes a supply chain problem or a digital software supply chain problem. But usually when I explain, attack patterns for APIs to practitioners, there's kind of a common ground. The types of attacks that are usually most well known, denial of service, right? We're all pretty familiar with that, where somebody is either trying to overwhelm network connections, protocol, taking advantage of design of the protocol itself, or maybe some weaknesses to inhibit availability, or they're taking advantage of something in the underlying code. So like some function that is expensive to the underlying compute, which can cause availability problems. So maybe like a hashing function in the underlying code, or a function within that code base that calls out to something else, right? If I can hit that as an attacker, I can create kind of an application layer denial service. So these denial of service types of attacks are pretty well understood. How you control them can change though, right? Like, mitigating those, volumetric or network, targeted denial of services is much different than protocol and app layer denial of service events. The other category of attacks that are pretty well understood other than access violations, right? Failing to authenticate and authorize somebody, is the world of exploits, right? And usually the phrase that comes up most often is OWASP top 10. You start talking about cross-site scripting or SQL injection, maybe something like cross-site request forgery. But it's usually a failure to filter inputs in the case of cross-site scripting, and next thing you know, you're kind of echoing back responses to the user, right? That's a exploitable type of vulnerability.
Mhm.
But those categories of attacks, are pretty well understood, and I'd say the traditional security controls we have, like WAFs and API gateways, with things like rate limits or message filtering to catch very well defined patterns that seek to exploit those things like lack of input filtering. So they're pretty well addressed. Where it starts to deviate, where these controls just don't really help as much. You actually mentioned one, which is kind of there's actually safety issues, right? When you start talking about machines and IoT scenarios, there's some like public, safety issues that kind of become apparent, but also things like data sensitivity, right, and privacy impacts. So just exposing data becomes a problem, whether or not somebody is attacking you or not. And the other is kind of abuses of business logic, right? And that's a really tricky one, because how one organization builds APIs is going to be drastically different from another organization, and how they code their REST APIs, or maybe they're building GraphQL APIs or gRPC. There's a lot of variance in what an API can look like and what that traffic looks like. And for machines, it's not always easy to parse, or they're really not built that way, right? They can't parse what our intent is as, people, like, well, this is the business case for this, right? This is what it should be doing. Attackers know this, right? And they know scanners aren't good at finding these types of issues, or WAFs or API gateways. So they look for those kind of abuses of business logic. And then you start to see attacks like credential stuffing or scraping, account aggregation, scalping, spamming. There's kind of this whole world of automated attacks or automated threats that really aim to abuse underlying business logic. And as we know, web APIs are kind of the primary mechanism you use to power your business logic.
Yeah, and I think one of the big differences when we're looking at traditional apps versus API-based apps is that an API really exposes that business logic, right? So it's I won't say it is relatively easy for an attacker to get access to even a authenticated application. Put a tool in the middle of the communication and start to map out the API and look for ways that it can start to manipulate. They can start to manipulate that logic.
Mm-hmm.
And you talked about some of the tools that are good at preventing or detecting things like the injection attacks. I mean, to me, those are really well understood, or fairly well understood types of attacks. We can look for patterns of traffic. We can identify when an attacker is trying to exploit something like a cross-site scripting vulnerability or a SQL injection vulnerability, and we can block those. But when it comes to these logic-based attacks, I mean, back to your point that every API has unique logic. If you and I are both banks and we're creating a bank mobile app, the API behind those mobile apps are going to be completely different, even though they serve they serve the same purpose. They're still going to be very, very different. And the reality is that these apps are also composed of multiple APIs on the back end. So we've got multiple layers of logic that are being put together, and it's really difficult, or it's impossible actually, to build a signature or a filter to look for a particular attack pattern in these very unique environments.
Yeah, and it's the reality is those they're kind of proxy-based mechanisms, but they're looking at a given request or response at, like, in point of time, right, or that particular transaction. A lot of these business logic types of attacks, you have to be examining traffic over time, right, and sequences of requests and responses. And it's not easy to kind of extract that, well, this is kind of a normal behavior, this is anomalous, right? Somebody is attempting to, maybe they're scraping our prices from, our booking engine or retail sites, and that's going to look different than a user that's just browsing our site, right? They're going to see prices, but they're not going to be requesting it, as much, right? So you like looking for kind of automation from the API consumer, and that could be very subtle, right? Attackers know that if they request too excessively, they're likely going to trip something, right?
Yeah.
So rate limits is kind of a very well understood construct, right? They've been around for a very long time. Every network-based proxy can institute rate limits. You certainly see them in WAFs and API gateways. Most organizations really struggle with defining effective rate limits for public, or internet-facing APIs, particularly things like e-commerce,
Yeah.
right? Because if you're doing a product launch or you're dealing with seasonal traffic, what should a rate limit look like, right? Like you want to sell the product, you don't want to inhibit API traffic, and requests might be coming from everywhere in the globe. You're not going to block consumers in a certain area, provided you're going to ship to them. But you want that traffic, right? So rate limits fall down very quickly. They're very hard to operationalize and scale. But attackers, even with the presence of rate limits, they know they're going to exist, right? They'll start launching requests against API endpoints. They'll see that they get blocked, right? And then they throttle down, right? Or they'll request another IP address, and they'll rotate through IP address space to evade those types of mechanisms. So yeah, security. You talked about how the security stack is broken. I mean, it's those mechanisms will work for some things, right? We don't want to abandon them,
Right.
but the reality is, like, application and API design has really moved beyond what they're capable of keeping up with, right? We need kind of newer technology that can look at this traffic over time, provide the context to, well, what is this API consumer attempting to do against my API, and then make some more intelligent decisions around, does it make sense to block this person? Should I maybe throttle them, like introduce some dynamic rate limits, present alternate content, right? There's a very wide spectrum of how you might react to somebody that's abusing your business logic.
Yeah, and you can't do that as a point in time. You need to look at a bigger picture or
Yeah, absolutely.
more data in order to make those decisions. I mean, the other point is that a lot of the reconnaissance activity, a lot of the activity, to figure out that there's an exploitable endpoint there is very, very subtle, right? We're not dealing with anything that oftentimes we're not dealing with anything that's going to trigger a rate limit because we're oftentimes the attacker in the early stages is acting as a normal user, mapping out the API and doing little subtle things to see how the API actually reacts. So you need to, ultimately put together, or if you have the ability to put together those pieces and look at the bigger picture, you have a chance of catching them much earlier in their process as well, which I think is kind of interesting.
Yeah, and you hear a lot when you have this conversation about advanced attackers, you'll hear things like low and slow, right? And that's
Yeah.
the reality. And it's exactly what you said, and going back to something you said earlier, that's really important for listeners to really grasp is, your client code, how users interface with your server-side content and those exposed APIs. It's open, right? It's visible. I mean, you could do things to kind of protect that code, whether it's JavaScript in the browser or a mobile application you're installing on somebody's mobile device through the public app stores. But the reality is that client-side code has to be runnable. And there's very well established techniques for reverse engineering client-side code. So it can raise the bar in a sense, doing some of those client-side tactics to make it harder for attackers. But reverse engineering of client-side code is a given, right? If you have something valuable enough, attackers going to figure it out. They can very easily proxy connections from their own device, right? It's kind of a local proxy as opposed to some proxy that exists in the network, as we might think of it as a security practitioner. And then they can see all the traffic, right? And then they see all of the API calls that that client code is making to backend systems. So it's very easy to kind of, pick apart that app. Like, I don't even care about the front end anymore. I'm going to target those server side APIs now. And that's
Yeah.
exactly how, attackers go about this, using intercepting proxies. Like, Burp Suite is kind of the tool of the trade for security practitioners, but also attackers, right?
Yeah.
Once you expose that traffic, the world is your oyster. You can kind of do anything you want against those APIs. So yeah, you have to kind of be more focused on, like, what am I exposing? Is it exposed in the right way? Like, is that data, is it necessary to really expose that? Should I be exchanging that with clients? And just presume that your API consumers can be malicious, right? So you can't trust client-side code. You can't trust data originating from, right? Like, this is kind of security 101, and it definitely rears its head again, in the world of APIs. So
Yeah.
you have to be doing things server side and looking at, how is somebody consuming my data and my business functionality that I'm facilitating with APIs.
Yeah. And it's more of the I guess the overall trend of how they're consuming that API or interacting. Back to your point, it can't be a point in time. It's not a transaction by transaction thing that we can look at, because first of all, you're going to miss a lot of the activity, or a lot of the malicious activity, or that there's sort of precursors to the big attacks, and you could potentially get a lot of false positives as well if you're reacting to each and every anomaly as a point in time. So I know, we at Salt use big data and AI and ML to capture a lot of data and analyze all the traffic, and we have the ability to kind of put together those pieces in order to identify, a user who's not just acting in an anomalous way, but acting in a malicious way,
Mm-hmm.
right? And that's something you can only do by looking at multiple proof points.
Yeah. Yeah, and the reality is traffic's going to look anomalous, right? Like, if you change the
Yeah,
API, everything's abnormal now, right? Because you've
that's right.
changed what normal looked like. So
Yeah,
that continuous runtime security, it's it can't be done without, massive data storage and the use of, machine learning and data training. Like, these are kind of, they're cloud scale problems. Like, it's not something that can be done with manual analysis, right? Like we were talking about with design reviews and threat modeling. Like, you're just not going to catch all these types of misuse and abuse cases.
yeah,
And things change constantly, right? And the other is, exploitable conditions in code, right? That's only one type of attack. And scanners, particularly as you try to squeeze these things into build pipelines as part of release process, I mean, you're kind of narrowing the focus. You have to, right? We need scans to finish more quickly. So we're looking for those types of vulnerabilities or exploitable conditions they follow well-defined patterns, right? And
yeah,
we've talked, at length about how business logic never will, right? That's the problem. So those scanners and, design time, development time, build time, security, yes, they're absolutely critical.
yeah.
And we should, continue to stress that, but you have to kind of go into it with the awareness that it's catching kind of one aspect of security issues. There's a much bigger world of, the API security issues you need to be concerned with.
Well, I think that's a great topic for a future episode. I mean, there are, there is no one, like anything security, there's no one silver bullet that's going to protect you from all the, all of the threats out there. And that's very true of API security as well. I mean, there's stuff that, and best practices that you can be doing pre-production, and there's stuff that you need to be doing at runtime, as you mentioned. So I think that's a great topic for us to dig into, maybe in an upcoming episode, and talk about
Yeah,
all the different
absolutely.
tools and approaches. So anyway, Michael, thank you for joining. Really appreciate your insight, and look forward to the next episode where we can dig in deeper on some of these topics. So
Thanks,
see you
Chris.
very
Looking
soon.
forward to it.
All right, thank you.